I wanted to talk a little bit about what I'll call a contingency plan when you're doing machine work and what you have to think about in case what you're trying to do isn't working the way you want it to work. In this case, I was trying to run this part, and I did do the setup part this way, like you see it right here with the steady rest on the part, just like you see it. In fact, I started with remember on the previous operation I used this 4-jaw chuck in the steady rest, and the steady rest jaws were moved back a little bit here to grab onto that heavy wall tube I bolted to the back of the 4-jaw chuck, and then I could adjust the chuck just like I would adjust this chuck to indicate the end of the part in it, and that worked fine. And it'll work for different kinds of setups, but when I put it on this one this way, well, actually I was doing it with the aluminum setup part, which is here, this part, and it has the same issue when I'm chucked on the part back here, and I've got the steady rest here, and I've got the chuck here. There's a distance between the chuck and the steady rest jaws back here. And so if you don't get that chuck just straight in there, you can have a little bit of trouble with this tube running out. But also, the force of the machining is way up here on the part. And that works all right if the part's solid in the middle. But this part has this slot milled in it, and it must be enough to cause a lack of rigidity in certain directions as the part rotates. If this makes any sense. So as you turn, even though this part here has well, this thing is just I cut the bottom out of a 5-gallon plastic pail. I do this quite a bit if I need this kind of thing, and then I cut a hole in it to fit on the part, and this just keeps shavings out of the roller jaws of the steady rest. That's what this is. But the fact that this part might have some different amount of stiffness back here when it's rotating apparently causes me difficulty out here turning. And because the jaws, the rollers of the steady rest, here's a roller I had changed when I first got the machine. These rollers were damaged and I had to replace them, but the rollers have a crown on them, and they're designed this way so that they can have a certain amount of give, or play in this direction. So when the part's on here, if the part has a little bit of run out or whatever, or if these jaws were square and they were not perfectly aligned to the part, it would be tending to pull these jaws of the steady rest back and forth like this in a very small amount, but it would cause vibrations, particularly if you have like the feed lines of your turning on here, and they're kind of like a screw pulling the rollers back and forth. And I've seen that where it causes vibrations in the cut and messes up your finish. In this case, though, the finish is really good on the part. So, the jaws are working properly, but the problem is that I think, because this is running true, and the steady rest is running true, and everything's running true, but when this part rotates, there's some kind of difference in rigidity or flex of the part maybe in this direction opposed to this way, and it's causing the bore and the turning. The bore here in particular has a close tolerance. It's got a -0 +2 thousandths tolerance on it, and it's going to fit close to a plug that I'm making. I made this before I started so that I have it ready, and this diameter here is turned down to the minimum tolerance of the bore. But in order to get this to fit in the aluminum part here, this aluminum part, I had to actually turn this bore almost to the maximum tolerance on one part just to get this thing to fit in, because it's sort of out around, and it's in tolerance and it would probably work, but it also is causing misalignments to the internal features here, and all these features internally are in relation to this bore, so it's kind of critical. The OD is just a thread. It's going to be an Acme thread, and there's a lot of tolerance on Acme threads, and so it wouldn't be so big a deal there, but this bore has to be held close, as well as the locations of these features in the bore here have to be held close to the bore. Or actually, it's this smaller bore in here that is actually the datum feature of this part. So if I have any run out here, and oddly enough there is run out here even though everything is running true, and I can't really figure that out exactly, and I'm not positive what the cause of this is, but I know what I have to do, and I have to move to my what I'm calling the contingency plan, which is to move the part back into the chuck. So I'm going to be chucking on here. Let me open the steady rest here. In order to move this part back into the jaws of the chuck, like I talked about earlier, I have to do something to the pieces in order to have everything running concentric and true to what I've already done up to here on the part. So I have to first skim the ODs. I have to chuck each part in there, get it running true in this chuck, and get it running true here and all the way along here as best as I can. And then I'm going to probably bring the tailstock forward and just shove this with the pressure of the tail center up against the end of the part. There's about 1/8 of an inch of material still on the faces here, and make sure it's running true still at that point, and skim this OD. And then here on all the parts, there's going to be a hole in here it's about 1.5 inches threaded hole that goes down almost to the center line of the part, and so I can afford to mill a little counterbore in here, similar to what I did. I had one right here, if you remember on the previous video, to maintain my alignment to this bronze area. I don't know if you can see that bronze area. See it? It starts about right here and ends about right here. This was welded on here, and it's going to be on the finished part just in this area right here. The part shaped kind of like that. And so all this area is going to get milled down actually to part of it to the diameter of the thread relief down here, and part of it a little bit bigger to this. You might not be able to see that from there, but there's a diameter right here. And so I can do all that. So it creates a little bit of an extra step for me. And then I'm going to take these jaws off the chuck, and I'm going to do kind of a strange thing, you might think, but I'm going to chuck onto this part kind of like this with these hard jaws, and I'm going to only chuck onto maybe about 1 inch of the part right here. And you're saying to yourself, well, why would you do that? You know, you're going to have a lack of a hold of the part, but not really. With a 4-jaw chuck, when you chuck onto something with serrated jaws like this, it isn't going to move. Once you dig those serrations in there, there's no way you can even move that part. This isn't like a scroll chuck. A scroll chuck, you really can't chuck onto a part as hard as you can with a 4-jaw chuck. 4-jaw chuck, you're pushing in with every one of these screws all the way around every jaw with a lot of force, and so these serrations will dig into this material, and that's all right because this is all going to be machined away anyway, about down to this diameter right here, a little smaller than that actually. So when I chuck onto here, what I got to do is lightly chuck it, and then I've got to indicate along this axis to make sure I've got my axial run out, you know, in 2 places 90 degrees apart from each other, and make sure that's running true, and then make sure my radial run out is running true, and then I really start tightening up the jaws, keeping the runouts good. And once I get that chuck, that part isn't going anywhere. But like I say, I have to have this alignment feature to indicate my C-axis rotational zero, and also this will give me a good spot to set my Z0 out here, because I'll put this hole in the exact relationship to the end of the part down at this end, so I'll know when I find this hole that my actual length of my part, or my zero, is going to be here somewhere, because the parts right now just have a rough sawed end on all of them, but this one I can actually set it here now, but the other ones I can't. So it'll form those two functions for me, and I'll have a good grip on the part right here, and I won't have trouble with my roundness and runouts and everything down here because of whatever this is causing. I don't know. Maybe if I put a dial indicator on there, you'd see it. Okay, let me just run it up to 0 here, and you can see just with me flexing it, I can move it without too much difficulty here. And so I think what's happening is these roller jaws are sitting here, and we got the force of the cutting here and in here, and it's this far away from the jaws, and it's causing, and you see that much flex right there is enough to throw me off. I'm just going to try this on the first part before I commit to all of that, doing all that on those other parts, although I think it's going to work all right. And I just extended the tail center into what I've already bored, because that's running true. It's still undersized on this end here on the ID, so I've got material to come out about 10 thousandths more to bring it out to size. But it is running true, so I stuck the center up in here and I indicated everything, and it's all running true. I took a skim cut on this OD, and I just ran a little 1/4 inch end mill in here at the location of where this hole for the in the bore, this threaded, I was wrong from what I said before. This is actually an 1 3/4 12 thread. It's a spiral lock thread. For the life of me, I don't know why anybody uses spiral lock threads, but anyway, these people do, and so I have to put that in there. This particular well, I'll go into that more in when I make a video on actually doing this mill work. But what I had intended originally to do was to do all this. The reason I've set it up this way to begin with was I wanted to do all of this end work, ID work and everything, and then put my plug in here and do all this OD work all at the same time. But I'm not going to be able to do that, it turns out, so I'm going to have to do everything on the end in this thread first, up in the chuck here, and then I can extend it out and put my my plug in the end of the part and run the tailstock up like I've got it now, and do all this milling on the OD to bring it down to size and shape. This is a little bit complicated, this milling on the OD, so maybe it's easier to do it this way in the end after all. to get it to run straight this way first. Pretty close, but it's not going to be perfect. By the time we start tightening the jaws a little bit, things are going to change, but we got to get it close first, because once you start to tighten these serrated jaws, you can't move it very much after that. So I'm just checking it roughly. I mean, I'm not getting real perfect every 90 degrees, but I just want to check it to see if it's straight. Now we're going to start to adjust the run out a little bit. I'm going to set it on 0 here and 100 and 0 here. See where I'm at. Okay, we're high about 62 thousandths there, so I'm gonna make sure I got a little tension on the jaw here. I'm gonna start backing off here underneath. Not too much, because I don't want the part to move too much in the jaws. I want to come to about 31 on the dial. Okay, that looks pretty darn good there. Let's see what it looks like out here. I mean, I could tap that up. That's like 1/4 of a thousand. Just see if I can even move it. Okay. Might have moved it too much there. Tap that one. Don't really like tapping into the dial indicator, but really don't have too much of a choice here. Might have made it worse, actually, rather than better. Not too bad. I'm going to come back here and check it again. Now I think I've got it pretty straight. Now I'm going to really tighten down on these jaws until I get them tight. I want to make sure those serrations really dig into the part. Okay, on those two, I'm going to go and tighten these two. And we'll check it again. Okay, now I pretty much can guarantee you that isn't going to move. Let's see how it looks. See how it looks further out. Here. If it runs within less than 1/2 thousandth, I'm not going to worry about it. Looks like it is okay. So now we've got to indicate that in and get our C-axis 0. We're gonna rotate the chuck. Okay, I'm gonna be happy with that. So that's our X and Y 0 point. That's pretty good there. It's not, I mean, I don't have the indicator on 0, but it's running pretty true. Okay, so we're going to set our C 0 point there. Okay, here we are with it in the chuck, like I talked about earlier in the video. And you saw me indicate it in, I showed that. And now we're going to proceed with the machine work on this end, or the finishing this part. Anyway, and then we'll start with the next one. And I think I'm going to show that in the next video. This video is getting a little bit long, and I know I didn't show any machine work, but I thought it was important to show what happens and what you might have to do to correct an issue you're having with the setup. I think it's better to, instead of fighting with the setup, like I've seen many people do this, they fight and fight with the setup because it's just not right. And it's better just to give up on it and go to your alternate plan, which you should have pretty much been thinking about in your mind when you made the first setup. At least I always do that, just because not everything works the way you might think. So anyway, thanks for watching, and if this is your first time seeing my videos, please subscribe.